Hi everyone, I'm Yashwant, student of SVC Bangalore. Now we are going to discuss about stack and its operations from the subject data structures. About stacks. A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end, represented as the top of the stack. Basic operation on stack: push, pop, top is empty, overflow, underflow. Push, to insert an element into the stack. Pop, to remove an element from the stack. Top, returns the top element of the stack. Is empty, returns true if stack is empty, else false. Overflow, happens when we try to push more items on a stack than it can hold. Underflow, it happens when we try to pop an item from an empty stack. Operation. The push operation in a stack involves adding an element to the top of the stack. Check if the stack is full. Before pushing an element onto the stack, it's important to check if the stack has reached its maximum capacity. If the stack is implemented using a fixed size array, pushing an element when the stack is full would result in a stack overflow. This checks ensures that the stack doesn't exceed its predefined size. Second point, increment the top pointer. The top of the stack is pointer or index that keeps track of the current position in the stack. When pushing an element, the top pointer is incremented to move to the next available position. Third point, add the element to the point. Once the top pointer has been adjusted, the new element is placed at the location indicated by the updated top pointer. Pop operation. The pop operation in a stack involves removing the element from the top of the stack. Firstly, check if the stack is empty. Before attempting to pop an element from the stack, it's important to check if the stack is empty. If the stack is empty and a pop operation is attempted, it would result in an error known as stack underflow. This check ensures that there is an element to pop from the stack. Next, retrieve the element at the top. If the stack is not empty, the element at the top of the stack is retrieved. This is the element that will be removed. Next, decrement the top pointer. After retrieving the element, the top pointer is decremented to indicate that the top of the stack has been moved down. Display operation. The display operation in a stack involves showing or printing the elements of the stack without modifying its contents. This operation is useful for debugging, testing, or simply observing the current state of the stack. First one, check if the stack is empty. Second, before attempting to display the elements of the stack, it's a good practice to check if the stack is empty. If the stack is empty, there may be nothing to display, and attempting to display an empty stack might lead to confusion or unnecessary output. Third, iterate through the elements. Fourth, if the stack is not empty, iterate through the elements of the stack, starting from the top and moving towards the bottom if it's implemented as an array. Display each element in order it was added to the stack. Fifth, print or show the elements. Sixth, print or otherwise show each element of the stack. This can be done in a loop or recursively, depending on the implementation. Isful definition. The isful operation checks if a stack has reached its maximum capacity, meaning it is full. Use case. This operation is commonly used before attempting to perform a push operation. If the stack is full and a push operation is attempted, it could result in an error called a stack overflow. And this is a syntax for the isFull operation. Is empty. Definition. The isEmpty operation checks if a stack has no elements, meaning it is empty. Use case. This operation is typically used before attempting to perform a pop operation. If the stack is empty and a pop operation is attempted, it could result in an error called stack underflow. And this is a syntax for is empty. And both function return boolean value that is true or false. Peek operation. The peek operation, also known as the top operation, retrieves the element at the top of the stack without removing it, and this is the syntax for the peek operation. Overflow and underflow. Overflow occurs when an attempt is made to push an element onto a stack that is already at its maximum capacity. If overflow is not handled properly, it can lead to data corruption for program crashes. Underflow occurs when an attempt is made to pop an element from an empty stack similar to the overflow. If underflow is not handled properly, it can lead to errors or unexpected behavior in a program. It's crucial to check for underflow before attempting to pop an element from the stack. Implementation of stack in data structures. Array. In array, implementation of the stack is formed using an array. All the operations are performed using arrays. Linked list. Very new element is inserted as a top element in the linked list implementation of stacks in data structure. That means every newly inserted element is pointed to the top. Applications. Function calls and recursion. When a function is called, the current state of the program is pushed onto the stack. Expression evaluation. Stack data structure is used to evaluate expressions in infix, postfix, and prefix notations. Balanced parentheses. Stack data structure is used to check if parentheses are balanced or not. Backtracking algorithms. The backtracking algorithm uses stacks to keep track of the states of the problem solving process. Advantages and disadvantages of stack. Advantages: easy implementation, fast access time, efficient memory utilization, enables undo or redo operations. Disadvantages of stack: limited capacity, no random access, memory management, stack overflow and underflow. Thank you.